This software will be practical for design engineers, steel fabricators, researchers, professionals, academia. The most advantage of this software is that it doesn't require an extensive knowledge background in this topic. And everyone, both experienced professionals and anyone who is new in this topic, can use this software.
Kia ora, I'm Troy, HERA's Chief Executive, and welcome to Stirring the Pot. Thanks for connecting. If you're new, here's what you can expect. We're going to be talking the tough stuff, the things that keep us middle minds up at night. There are many challenges facing our industry and equally many opinions on how we should tackle them. Stirring the Pot provides a facilitated forum to discuss and challenge these viewpoints.
So let's get to the nuts and bolts of it. Today we're having a kōrero with Maryam Hasanali, HERA's Structural Research Engineer on CompWebPen, HERA's latest software to launch soon which will help optimise composite flooring systems.
Tell me about your background at HERA.
I am a structural research engineer in HERA, and my work focuses on the development of the design solutions for the metal industry. I received my PhD in structural engineering at the 𝗬𝗴𝗶𝗲𝗏, which gave me a deep insight in both research and practical applications.
Okay, thank you. What is your role at HERA?
You know, what we are doing at HERA depends on the industry feedback that we have received. And currently our top priority is the development of the design guides and design tools to support our HERA members and wide Aotearoa New Zealand and New Zealand construction industry. And so we also lead research projects. We are working on the collaboration with industry stakeholders to provide best engineering practices for them. And we also work on address the technical questions and developing the training and education.
Yeah. So you have a wide range of projects from the design guides to the tools and so many. Tell me more about, you worked with a lot of steel and composite structures. What are these composite structures?
Composite structures are actually a combination between two or more materials when they work together. One of the examples can be the combination of the steel and concrete, where these kinds of combination provide the lightweight of the structures compared to that just one material works.
Yeah. So you can take the advantage of both the materials and their strength into the structure. And why you think they are important in construction?
Because, they are kinds of sustainable solutions for the structures. They can provide, while we have two materials, we can have more strength, lighter weight, higher durability, higher load carrying capacity without more material usage and cost. They are also cost effective. They can also help to the reduction of the carbon emissions.
So using the best of all of them. So there are many kinds of composite structures: steel timber, timber steel, steel concrete. Steel concrete is the most common one. Can you give me some examples where they are more commonly used you can tell about?
Yeah, you may find them where the strength and lightweight matters more. For example, in the bridges and high-rise buildings, and where the places like train stations and airports. In the bridges, it's quite important because they keep the line distances while keep the cost and materials down. And also in the high-rise buildings, they can help to have higher load carrying capacity without adding more weight into the buildings. In the airports or train stations, you can have them because to support a longer distance and without too many columns, so they will be more spacious.
Yeah, they look spacious like an airport. You don't want columns in between so that you can have long span. No hindrance in there. And you talked about you use it in buildings as well. So are they used in a flooring system?
Yes, they are quite common to use in the flooring systems. They are important because you can take advantage of the high tensile strength of the steel and the excellent compression strength of the concrete at the same time. They will help you to have more load carrying capacity, reduction of the deflection, while adding more weight into your building. So it can help the reduction of the material usage.
Yeah.
And also they will be more cost effective.
Okay. No, excellent. Excellent. It's been in a use for quite long in the industry. And as I know that HERA is working to develop a software which is called CompWebPen.
Yes.
And tell me more about this. What does it do?
HERA CompWebPen is a standalone design software that was developed for the design of the composite steel concrete beams with web penetration. This software is developed based on the Australian New Zealand design standard 2327. And this software is integrated with the available HERA web-based composite beam and slab software. The users can import the data from the web-based software. They can have the basic beam data using XML file, and also they can import the loading conditions, while they can also import and change the data at the same time, and they can define any kinds of web penetrations, any configuration, any size in this software. This software can provide also, all design regulations and provisions to the users, and they can easily review the results.
No, excellent. So HERA already has a web-based composite beam design software.
Yes.
And this is for the web penetration. Yeah?
Yeah, exactly. Web-based software was developed for the design of the composite beams.
Okay.
And CompWebPen is specifically designed the beams with web penetration.
Penetration.
Yes.
Oh, excellent. I think it's a step ahead.
Yeah.
So the HERA has taken another step in this field. So you already had this composite beam software with HERA. What inspired you to develop this web penetration software?
What inspired us was driven by the widespread use of composite steel concrete beams with web penetration, where it is quite important to transfer the plumbing, mechanical, and electrical facilities from these beams. So they are quite common in the industry. And the other thing was that from the feedback that we have received, there was always challenges and issues between, for the design engineers and steel fabricators for the design of these kinds of structural components, because it's quite time consuming for the design of these elements. And so we have decided to develop this software to provide a unique and also best engineering practice to save the time to support the HERA members and provide a more efficient and reliable design tool for them.
So in a way we can say that, because if you have a composite beam, you have lots of plumbing, lots of ducts going here and there.
Yeah, exactly.
And at the construction, when it comes, you realize, we need to penetrate the beam.
Yes.
So what people used to do before they didn't have this software? What was the conventional way of doing it?
Just based on hand calculation, and also I know there are some software available in the world, but they are not particularly for the New Zealand.
Yeah,
and
sense.
Also they are very costly compared to the price of this software, because this software exactly align with the New Zealand design standard.
Yeah.
And it will be more efficient than the available one.
Yeah, no, that's true. I had so many incidents back in the past where you design everything and then you come back and say, the contractor calls you, this duct we need to penetrate this beam. What can you do? And we are like, we are stuck. We don't know what to do next. So you go back, do all the calculations, and then it takes so long to come up with something.
We always heard that there are many challenges. Design engineers, because it's quite computationally expensive to design these kinds of buildings, and there are some challenges in their conversation. So this software can provide a streamline design and quite transparent output. So it will help them.
Yeah. So basically, you can use the HERA web-based composite beam design software You can extract the data, put them in here,
Yes.
and put your penetrations in there, and it will do the job. So it's like a one-stop solution for designing the whole composite beams with the penetrations as well, if
Yeah.
you need it.
Yeah,
No,
exactly.
excellent. So you already talked about, tell me about the development process, how that happened.
The development of this software was a kind of combined research project and a software development project. It was challenging due to the lack of correct technical solutions and due to some issues in the Australian New Zealand design standard for the composite steel beams. And so during this process, we have conducted a true investigation of the international design standards. We compared them with the New Zealand design standard provisions, and we have provided the most accurate one and New Zealand aligned design regulations. So it took maybe around 1 year or over to develop the software. And I'm quite happy to share that every details and every design regulations will be shown in the output. So engineers will be able to see any equations about.
Oh, excellent.
Yeah.
So they know what they are dealing with, what is the output, what went in there, how it has been calculated.
Exactly.
So it's
Yes.
quite detailed.
It's quite detailed.
Yeah.
And it will be very fast.
Yeah.
Yeah.
You talked about that they will be able to see those details. So does this software ensures that the beams are designed the safe according to the codes and standards? So they will be able to see that there?
We have tried our best to provide all alignments with the New Zealand design standard to ensure that all design regulations and equations are aligned with the New Zealand design standard, and also a comprehensive verification plan was done, and every details of the software such as XML data input, user interface, all details of the calculations, and ensuring and verifying that all details are aligned with the design standards, and how the software can provide the output to the users. All of them were truly investigated through the verification plan, and it took, for example, several months to complete them. And also during a trial program, we have sent the license of the software for selected HERA members to test the reliability of the software. And also, I'm happy to share that no issues were recognized.
Oh, that's
and
so
the
nice. Good to hear
engineers
that.
can confidently use this software for the
Yeah.
design of this structural component.
Yeah, this looks like a long verification process.
Exactly.
You did it in-house. You approached the outside
Yeah.
in organizations as well. Made sure it is thoroughly verified. No, very good. So based on your thinking when you developed this, who was your targeted audience? Who do you think will be using this software? And how does it help them?
This software will be available and practical for design engineers, steel fabricators, researchers, professionals, academia. And the most advantage of this software is that it doesn't require an extensive knowledge background in this topic. And everyone, both experienced professionals and anyone who is new in this topic can use this software. So this software will be available for all HERA members and all construction industry in a cost-effective way. So it can provide high quality design tool for engineers that with confidence they can use this software.
So you are making life easier for designers and engineers and the fabricators to use this software. No, very nice. So I think the industry will be thrilled to have this. And I think it's a very nice one where they used to do the hand calcs before, and now they have something they can rely on which adhere to the Australian.
Can be a kinds of sustainable solutions.
Yeah.
A manually calculation of these structural components can be computationally expensive. So using this software can provide a significant lower time than the previous one. So they can save time. That lastly, it leads to the saving of the money.
Definitely.
Money and time are related. Together, so.
Yes. No, very true.
Yeah.
The more you save time, the more you save money. That's so true. And the good part is it adheres to the New Zealand standards. So you know that you are relying on something which follows the guidelines and the rules and regulations. Oh, that's such a good research, and happy to know about this. Tell me, what's the next research for HERA? So you guys must be working more on some other stuff as well?
Yeah, quite extensive projects. As part of our pioneering research project focused on the sustainability and circularity, we are working on the development of the reusable seismic frames, considering the carbon emissions associated with the initial life cycle of the steel projects. Reusability instead of landfilling or recycling them can reduce the carbon emissions significantly.
Oh, definitely.
Yeah.
Yes, yeah.
And we also working on another software development which is called CompWebPen, can analyze and design of the composite steel concrete flooring systems. And also there is a recognized need for the New Zealand for the development of a design guide or adjust another one for the hybrid steel timber flooring systems.
Okay.
We have recognized several knowledge gaps, so we are trying to focus on them and address them. And also, in order to share knowledge, we have several training sessions, such as webinars and seminars for the engineers and steel industry, and that will be released during this year.
Oh, excellent. It's a wide range of projects.
Yeah.
I must say, HERA is doing a really good job, and so many projects from sustainability to the tool development to the design guides and the reusability of steel structure. That makes life so much better for the next generation as well. And now, thank you for telling us all about this CompWebPen software. And I'm sure the industry will be very excited to have this.
Thank you.
Any closing thoughts on this you want to convey to the industry?
To me, staying engaged with industry is quite essential for us because we can get ideas from them and to see what is exactly their problems, what are exactly their challenges, and then start to address the challenges and issues. It's quite important for us. And, technology, another thing can be the technology. Technology play a key role in the development of the best structural engineering design solutions. By using the technology, automation, and data-driven solutions, we can provide the best engineering tools to support the HERA members and also all construction in New Zealand. And sustainability and development of the circularity, as I mentioned, is one of our top priorities. So during our developments, we not only want to provide seismic design solutions that can advance the resilience against the natural hazards, we are trying to reduce the carbon emissions and environmental impacts.
So there you go. Thanks for joining our conversation with Maryam today. If you'd like to connect more with her, you'll find her details in the show notes. With tools like CompWebPen, we're able to make smarter design decisions that push the boundaries of what's possible in construction. As we continue to innovate, one thing remains clear. The future of our built environment depends on the clever integration of materials, technology, and expertise. Food for thought till we see you next time. So hit subscribe, and if you like what you heard today, please like, review, or share with any metal minds you know. Let's spread the word. If today's kōrero has got you curious about the CompWebPen, then great! This brand new software is designed to support engineers in optimizing composite flooring systems, helping to streamline design, support compliance, and improve efficiency. And the best part? It's live and ready to use. Time to level up your composite design game. You'll find details in the show notes.